people who think ships are disappearing over the curve in 3, 4, 5 miles distance, it's got to work both ways. I mean, if we're on a ball, then when the ship is going away from you on the, let's say, the z-axis, going, from you to a point away from you, and it's rolling over the ball in 3 to 5 miles, then you should have the exact same effect looking left to right on the x-axis. You should be seeing ships rolling up to the top of the ball and rolling down on the lateral x-axis. If it's a ball, they got to be rolling both ways, away from you and side to side. We never see that though. You can go to the beach and do a panoramic shot and put a parallel line over it, and from end to end, and this is a lot more than just 5 miles, there's no perceived curvature here. None. Flat as a pancake. And in fact, these are some pictures I took on the beach at Malibu, California. And I went from there way up into the mountains above Pepperdine University and looked out. And I mean, easily there's got to be probably close to 100 miles left to right. The distance on the horizon there it's got to be, quite a bit there. Put a parallel line over it, flat. So you can't have it both ways. You can't say ships are rolling over the ball on the z-axis without having the same exact perception on the x-axis. Okay, going back to this picture right here, showing the perception differences when you're zooming in and out. Here's another shot right here. This boat came into view as I was zooming out. Zooming out, zooming out, zooming out, and it rose higher on the horizon. See, when I was zoomed in on him, there's all this space right here from the bottom of the boat to the horizon, and when it's further away, that distance shrinks. So our eyes start playing tricks on us. Now, to better illustrate this, I created this little animation right here, and this represents about a mile worth of ocean. All right, so when you're looking, you can see the difference in how each of these ships looks like it's higher and higher up on the water level. Now that's on flat water, no waves at all. Now let's look at this same animation. I created some waves no higher than the height of the camera. In fact, a few times you'll see the camera go right through the waves, but the wave height was about as high as the camera, which was just a little bit above the water. Okay, so let's look at the same exact animation, this time with some waves. Okay, there's a wave, 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 wave. Okay, over the distance here, the cumulative effect of the waves obscures the hull of ships. That's just what happens with the perspective. As the ships get higher and higher up on the horizon, as you get further and further away, and you have the compounding of the waves over that distance, it's really easy to see how you end up with the illusion of ships rolling over the ball when it has nothing to do with that at all. This is a flat plane. Here's the two pictures side by side with flat water with no waves and then with waves. In both cases, the more distant ships rise up on the horizon, but in the picture on the right, you have the waves obscuring the hull, and over the distance it accumulates, so you lose more and more of it. The other big problem with the ships going over the curve argument is what happens to the horizon when you go up and down on the y-axis. When you go up on the y-axis, the horizon doesn't change. Now, let's assume we're looking at eye level right there, and the horizon's right across our eye level. When you rise up on the y-axis, the horizon stays at that same level. Well, maybe it's hard for you to see in this animation, so let me do more of a basic one right here. Here's the horizon right here. If I go down, it stays the same on a plane. And if I go up, it stays the same on a plane. That cannot happen on a ball. If you saw ships roll over the curve on a ball like this, the horizon's right there. The only way you're going to see that ship is to rise up on the y-axis, but when you do that on a ball, you lose it. Now, here's a more practical example. Just watch cars go over a hill. Get down on the ground. This is my iPhone. I put my iPhone on the ground. I'm watching cars drive by. There's a nice truck right there. They're about to go down a hill. And now here's the horizon right here. This is, the horizon to my camera. And if I want to see those cars, I just have to rise up on the y-axis. Now, I didn't keep it all steady right there, so as the camera comes back to pretty much the same level that the eye level of the camera, as it were, you see the distant horizon right there is the same. It's exactly the same. Now, again, that was sloppy because I was just doing it with an iPhone, and my hands didn't keep it exactly the same. But if you were to rise directly up on the y-axis with a camera on a tripod or a crane or something like that, you'd have the same exact thing that you observe anytime you've flown in an airplane. Doesn't matter how high you go, that horizon just follows right up with you outside your window. When you're sitting on the flight line, you look out, there's a horizon at a certain level, and when you fly up to 35,000 feet, that horizon stays at the same level. That cannot happen on a ball. On a ball, when you rise up on the y-axis, there's no way the horizon is going to rise with you, especially if you think ships rolled over that curve in 5 miles of distance. If you lost, 20, 30 feet of a ship disappearing over the curve, then just like the example of the cars, if you want to see those cars again, you're going to rise up on the y-axis and look down at the ever-increasing slope of the hill to watch that, truck or car or whatever continue down the hill. The same thing should be if you're watching ships disappear over the ball on the z-axis in front of you, in 5 miles distance, and you're losing 20, 30 feet worth of the hull, then you should rise up on the y-axis, look down the ever-increasing curvature of the ball to see that ship receding away on the curve. But that doesn't happen. You see ships go away from you on the z-axis, but there's no indication of the same exact curve on the x-axis, and when you go up on the y-axis, the horizon pops up with you. That should not be if we're on a ball.